stop throwing exceptions. It's my presentation. I also written an article on this. I will share that later. It had some comments, so I hope it can spark some debate here as well. So first of all, we have the traditional error handling. So you can try something, and then you can catch something, and then you can handle the exception. That is like very old school way of error handling. And in Kotlin, we have the amazing thing that the try catch is actually a statement that can return a value. So in Java, we don't have the luxury. To be fair, I made this presentation originally for also a backend audience, so I'm very happy that Attila is here. That's why I don't have Swift examples, but Java examples. And when I figured, I think yesterday there's Java examples, I felt myself not sure enough to change it all to Swift and be correct. So I left it in a Java example. So in the Java world, you can do it as the following. You can return the thing you try, and then you can return something from your catch. And in Kotlin, you can just make it shorter. And also in Kotlin, there's this one annoying thing here. If you do some code and you try it and you're inside a suspending function, for example, you really would have to catch the cancellation exception. So if you do any work with coroutines, you have to catch the cancellation exception and rethrow it because the work needs to be canceled, but you can catch the cancellation. So this is kind of annoying that you have to keep track of this basically all the time, everywhere. So there's another simpler way in Kotlin to catch an error, and you can run a code inside a block called runcatching, and it will be captured in a result object that can be successful or failure. And you also have flows in Kotlin, so didn't find a Java equivalent, to be honest. So you have a flow, you can emit some values, you can collect on it, and you can also add a catcher to catch all your errors. And the flow catching, I think that handles cancellation exceptions, by the way, so here you don't have to worry about those, but still, it's not so pretty. Now, exercise for this room. Which function is throwing an exception? This is actually what you will see in a pull request. If you are in an IDE, then Java will give you a nice red line, which one may throw an exception if you have defined it. So if it's not, a runtime exception. So to me, this code is hiding a bit what it can or cannot do. And therefore, throwing and catching is ugly. I don't like it. It has a happy path focus because, you have to try and catch something. So maybe you will just ignore it. I mean, nobody's really forcing you to use it. So you can just focus on the happy path. And we are really unsure what code will throw what exception when exactly. I mean, can depend on the programming language when it's better or not. But in Java and Kotlin, and especially Kotlin, this is a problem. So I'm going to show you I don't like it. And then I'm going to show you how I do like it. And I will also show some of my ideas on this topic. So let's say we have a sealed interface, a view state. It can be successful, it can be loading, and it can also be a failure. And if you have a view like a composable, then you can have a when statement, which is just you can switch between the states, pattern matching in Java. And then you can show different views based on what state we feed to it. And usually the state is coming from a view model. So this is kind of okay. I mean, this sealed interface is not really elaborate, and maybe I would do it a tiny bit different, but that's not the point. So let's look at the view model. I have a view state. Normally, you would first define a private variable, which would be mutable. And then you expose a non-mutable variant of it. So that's what we do here. For this example, we don't care because we don't care about this exposing. We care about exception handling. And it takes less space. So let's see. We have some code. We fetch some stuff. We map it in some mapper to a view state. And then we update the view state with a new state. Oh, and of course, we have to try catch everything because, maybe our use case will fail. Maybe to make a backend call. The backend call fails. It cannot return the value. And of course, what do we miss? Almost in the same place. No, also, by the way, yeah. So we miss the error handling here. Oh my God. Okay, so we can do a different coding pattern that we actually do some error handling, but yeah, it's really the way of writing. So then we use it as a return statement that, yeah, the try catch has to return a value, and with that new value, we can update something. I think we can do better than this. And I don't like throwing and catching things because, yeah, the first example would compile perfectly fine, but we will have issues later on. And then we have ugly code like this. So we can also wrap our things in a result object, which some people may call optional or whatever. I like to call it result because it's either good or bad. And how I would write it would be something like this, like you have a sealed interface. And with your sealed interface, you can have a success, a failure. So either you have a value or you have a throwable or exception. And then you can write like the API for it. That's how I would write it. And you have a success and a failure. So if you want to say for a simple result object, get the value or null in case of an exception, that's how you could write the method. But Kotlin has a different result class. And I thought it was kind of interesting to have a short look here. So first you see it's a generic class, so it can be of any type. So the result will wrap around every type you give it basically. But we notice it's an inline value class, which means Kotlin that during runtime, the value of the class is unboxed. So that means if you have a result of a string, you don't have two objects in memory, like the result with the string, but just the string. So that is memory efficient. And also during compilation time and during your coding time, you have to have a result of string. So you cannot get away by assigning a string to it. So it's type checked, but less memory in, how do you call it, in actual runtime. And that's different from my solution because that will wrap the result inside another object. You can also see it has an internal constructor, so we cannot access it. And the value is also internally, so we cannot access it. Finally, the type is of any with a question mark and not our T generic type. And this is because it's a result class. It will cast the value to the type T in case of a success. And in the case it has an exception as the value, it will return a throwable. So that's how they kind of hack around it. Can look deeper into it. I don't think it's necessary. And I think nobody really cares except for me. So how do we use it? So if you have, so you have like static helper function in the companion object of the result class, and then you can make a success or a failure like this. Both functions just return a result object, so not the result.success because that doesn't exist. And we can write it a bit shorter. You can say success failure if you just do the imports, right? And you can access it by calling on success, and you can chain that one with, for example, on failure. And if you can imagine, if we call on success on a successful result, then it will print out, in this case, hello. And the on failure will do nothing because, yeah, the success result is successful, so we don't have a failure. Same goes for a failure result. On success will do nothing, and on failure will now run. We also have a way to map. So if you have a result, we can map it into another result. So in this case, it was a string and it stays a string. But we can also map it to any other kind of object. So that's very nice. And there's a nice function, get or null. I showed my version of it. This does basically the same. So if your value has something, the get will return value. If it was an exception, it will return null, which you can see here. And also there's a get or else, and it's very simple. You can get the value or else you return this value what you define here. So the failure in this case will return 0 instead of the count of the string because it was an exception, so we return some other value. So in this case, you are kind of forced to either deal with the nullable object or you give it a nice value. And there's a nice folding function which can be used to basically declare if it's successful, we return this, and if it's not successful, we return that. And you can also do your error handling in here. So easy enough. So let's look at the Android code again. So we have our try catch mechanism, and now we can do something different. So now our use case is not returning a value that may or may not throw something. It will return actually a result object. So our stuff is now wrapped inside a result. And here you see that, yeah, you have to either get the value or else we will provide a failure state. And I didn't want to fold it because you can write it a tiny bit shorter, which does exactly the same. But what I also like to do is I have a mapper, and now I only map the actual object inside the mapper to a view state that my UI can understand. What if my mapper just takes the whole result object and returns a view state that can be either a failure or a success? And now my view model looks super clean and the errors are handled. And my mapper does the logic for handling the failure and the successes. And in this case, it's very easy to test as well because my view model doesn't do a lot. There's no if else, there's no switching. So every time I want to test something, I can really test the functionality of the view model itself. I don't have to test the mapper. Because for the mapper, I will have separate test cases. And there I can easily test them because that is a function.map. I can put in a result that's successful, check the output, and I can put in a result that is a failure and check just the output. So it's really input-output without side effects. So how does the use case look like? So it's very simple. We define the interface. Could be a fun interface, doesn't matter. But we just run a function or run the use case and we return a result of something. And the implementation looks like this. So let's say our use case should return a result of something. And we have a 3-step program. So we have to fetch the user. With the user, we fetch like a secret. And with the secret, we can fetch the secret data. Ooh. Now, first, the dependencies I just hidden because otherwise it gets too large. But just trust me, the fetch logged in user use case will be injected into the constructor. And we can run it. And that will just return a result object with a user. And this will get prettier, but let's go look at this out of the box version right now. So with the user, we can map it to the secret for the user. And the interesting part here, we either get that secret and then the map will return the secret, or we return a failure for the whole use case. And we can map that secret also that we fetch something with the secret from our repository. And there as well, we either get it, so our mapping will return this something, or else we return a failure from our use case, which I have to say, I'm not very satisfied with this. So what I want actually, I don't want to map an object to another object. I want to map a result to another result. But if you do that, you can imagine that if I map one result into another result, I will have a result of my object. So what I need is something like a list of a list and then flatten it, which we can call flat map. Oh my God. And it's so simple. Which in Kotlin, you can just make an extension function. So on every result, you can flat map it into something else. And it's very simple. We either get the value and then transform it into a new object, or return the failure of the original exception, and then the chaining basically ends. So that's very simple. And this with a contract in place to look more professional. So if I change our use case like this, it will be much simpler to write, and also I hope much simpler to understand. So basically, we first try to fetch the user. Then we can flat map the user to the secret and flat map it to something that we get with the secret. If the first logging fetching of the user fails, then it's simple. That failure will be returned right away. If the secret fetching is failing, then we return that failure. And the same goes for the repository. We can return that failure as well. So this should look simple. And in case you have any questions, let me know, by the way. I don't know what I was thinking, but I made a Java implementation for the whole thing just to show it was possible so nobody complains. You can probably just copy paste it from the slide and it should run, and it has all the functionality that I'm showing right now. Other than that, I like to move on. So there is one more thing. So here is the same code, how it looks in Java, and I have to say that this, pictured in your mind, this looks mighty similar. So you can actually do the same kind of things in multiple programming languages if you are really trying hard. Now, Then there's one more thing I like to do, not just mapping, mapping a successful thing. I also would like to recover if I have a failure. So in this case, I have a failure. And what you can do is you can recover. And that means whenever you have a failure and do a recover after that, then if you have a failure, you will get the new result object, which will be a success. So here you can see that even the original was a failure. So we managed to recover it. And now we have the message, I am recovered. Great. So you can see that the recover function actually returns a result. So it's not like the get or else that it returns the actual object. No, it returns a new result object. So that's good to know. And it would also be nice, in my opinion, that if we recover, that we can try just a whole different way to gather information, which may also return a result object. But just like the mapping, if I try to recover with a new result, then the failure result could be a string, or it could be a result of a string. So the final result type will be any, which is not what we want to see. So we want to have a flat recover that can basically, take a new result object and then merge them together with the original one, and then try to recover the result. Great. So why do I want that? So let's say I have a repository and I like caching. I have a database, I have some memory cache. So first thing I want to get the data from my memory because it's really fast. If that doesn't exist, I want to get the data from the database. And if it doesn't exist, I want to get the data from the network. That's, I think, a fair strategy. And of course, in between, I want to store the updated information in all the places. So let's see the implementation of this. So first we have the memory cache. We get something. It returns a result object. If it's not there, it will return a failure. And then we try to flat recover it and we try to go through the database. And if that's successful, we update that value inside the memory and we return the result of the database. Let's say the database is not being able to handle it. We try to recover from the network. Maybe somebody is watching a lot of YouTube videos and your network is unstable. So it may fail or not. So in this case, you can see that with our flat recover, we can do like a caching strategy that we first try it from memory. If not, we try from the database. If not, we get it from the network. If the network is successful, we store it in the database. If either the database or the network is successful, it will finally go into the memory. So here's no if else, if this is good, if no, we just chain the things like a sort of functional programming. And let's say we put it all together. So we have my view model and I just went over all the different ways that we could get our data and store it and whatever. So here I'll put it together so you can see that we use the same kind of coding style everywhere in the app. So first, we fetch our user, we fetch the secret, and then we feed the secret into the repository. Which is basically we get it from the memory, and then we get it from the network, and then we update the memory. I skipped the database in this part, but it's not so important. And at the end, I fold it into something that the view understands. So we can either pass a success state or a failure state based on all the work that we did before. And if I would do clean programming, it would look something like this. We have a nice use case that can fetch the data, the mapper that can map it, but the whole implementation of those three layers, like the use cases, the repository, and the mapper could be almost like this, which I think is quite a small size of code to achieve quite a lot. So to summarize, I talk much faster than I thought I would. We can and we should use result to pass down our data. I have to say, it doesn't need to be result, this particular Kotlin class. I would just suggest something else that you know works or that you create yourself and therefore you know it works. And Why should we do that? Because we will no longer live in fear that we forget to catch some kind of runtime exception. And especially in Kotlin, it's important because there's no checked exceptions in Kotlin. Yeah, but also in Java, there's a lot of runtime exceptions. So we don't have to worry about it anymore because we stopped throwing exceptions altogether. And in Kotlin, at least, you can use the existing functionality and make your own extensions, like to map and recover in my case. And in the mobility project, this is happening as we speak. That was also the motivation. And there, I think we could really cut down on lines of code, if else statements, and basically the whole complexity of all the mechanisms there. And I can say that result you can use in almost all your application layers. So for me, the cutoff would be at the view model. So a view model may still use a result, but it doesn't expose it to the view. But if you have a use case, or you have a repository, or you have a data source, or you have a, I'm now trying to initialize Nevis. Guess what the initializer returns? A result object, super great. So everywhere you can use it, everything that can fail can return a failure. At least a result failure. Everything that never fails can just return the object. So you don't have to, but can almost use it everywhere. However, it's not a sealed interface in Kotlin, so you cannot do pattern matching. But to be fair, you will overcome this in, I would say, 10 minutes. So you'll be fine without this. And if you make your own implementation, you can still do pattern matching. Now, that's great. You can still throw exceptions, by the way, if you want. Just make sure that your whole application goes down with it as well. That's the most important part here, because in that way, you will treat an exception as the case that you want to crash, which usually you don't. So, but you can. So just feel the freedom that you can, even though you shouldn't. Other than that, you can still also throw exceptions, for example, in test cases or whatever, because then it's fine. And even though we don't throw exceptions anymore, we should still catch them. So be aware that even if you're super used to not throwing them anymore, that at the edges of your project, that you still catch them in a nice way and then wrap them in a result object. Because maybe that library over there will still throw it, or your networking layer will throw it, or whatever. Or no, not your third-party network layer will throw it. So be aware that it can still happen and that you catch it nicely.